So in this example, we want to write an augmented matrix for each of the following systems of equations, then use a graphing calculator to put the matrix in reduced row echelon form to solve the system. So we have two different systems that we want to solve using this approach. So the first thing I want to do is put this equation in row echelon form, and then we'll use the calculator to put it in reduced row echelon form. So writing this in row echelon form, we're going to use the coefficients and the constants to fill in the values in the matrix. So 3x minus 4y minus 1z equals 6. So that row of the matrix represents the first equation. 2x minus 1y plus 1z equals negative 1. 4x minus 7y minus 3z equals 13. So here is our row echelon form for the matrix. Now I'm going to use my calculator to put this in reduced row echelon form. So I bring in my calculator. I'm going to go to the matrix button, so second in matrix. We're going to edit, and I'm going to use matrix A. Well, in this case, we have 3 rows and 4 columns, so I have to tell the calculator that we have a 3 by 4 matrix, and then I'm going to fill in our values. So 3, negative 4, negative 1, 6, 2, negative 1, 1, negative 1, 4, negative 7, negative 3, and 13. So I have my matrix entered into the calculator. I'm going to second and quit to go back to the home screen. I'm going to go back to the matrix button, so second and matrix again. This time I want to do math, and I want to put this in reduced row echelon form. So that's option B on my calculator, and I'm putting matrix A in reduced row echelon form. So when I do that, I get this result: 1, 0, 1, negative 2, 0, 1, 1, negative 3, 0, 0, 0, 0. So 1, 0, 1, negative 2, 0, 1, 1, negative 3, and 0, 0, 0, 0. Now when I get this full row of zeros, recall that that means we have a dependent system. So this is a situation where we have an infinite number of solutions. So the fact that we've got that full row of zeros tells us that we have infinite number of solutions. Now that doesn't mean that all solutions work. That just means there's an infinite number of solutions, and so we need to describe those solutions. So looking here, this first equation tells me that 1x plus 1z is equal to negative 2, and the second equation is telling me that 1y plus 1z equals negative 3. And so we can use this in order to describe our solutions. So for whatever number I pick for z, I can figure out what x and y has to be in order to be a solution. So if I solve for x, I would get x equals negative z minus 2. And if I solve the second equation for y, I get y equals negative z minus 3. So for whatever value z is, x is going to be negative of that, minus 2. And for whatever value z is, y is going to be the negative of that, minus 3. And then z. So this is a way of writing the solution to this dependent system. So for example, if I were to let z be 5, then x would be negative 5 minus 2. That would be negative 7. Y would be negative 5 minus 3. That would be negative 8. So negative 7, negative 8, 5 would be one possible solution to this system. In the same way, if I were to let, say, z be 0, then x would be negative 0 minus 2, which would be negative 2. and y would be negative 0 minus 3, which would be negative 3. This is another solution to this system. And I could do this all day. Pick different values for z and figure out what x and y has to be, and there would be an infinite number of possibilities. So here is our solution. There's an infinite number of solutions, and they would have this form: negative z minus 2, negative z minus 3, z. And then here are a couple of those infinite numbers of solutions. Let's take a look at B. In B, we have the system x minus y plus z equals 15, x plus y plus z equals 9, x plus 3y plus z equals 2. So let's start by writing that as an augmented matrix. So 1x minus 1y plus 1z equals 15. 1x plus 1y plus 1z equals 9. 1x plus 3y plus 1z equals 2. So I'm going to enter this matrix into my calculator. So again, matrix, and we're going to edit, and I'm going to use matrix A. This matrix is a 3 by 4 matrix, so I'm just going to enter in my values: 1, negative 1, 1, 15, 1, 1, 1, 9, and 1, 3, 1, 2. So second quit, go back to the home screen, back to matrix. This time I want to do math and reduced row echelon form and matrix A. So I want to put matrix A in reduced row echelon form. When I do, I get this result. So 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1. So this matrix reduces to 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1. We'll focus again on this third row, 0, 0, 0, 1. That means we're getting the statement 0 equals 1. 0x plus 0y plus 0z equals 1. And that doesn't make any sense. 0 equals 1. I shouldn't have put a not equals through that, but that's what this statement's saying. 0 equals 1. Well, that doesn't make any sense. So when we get that kind of result, that indicates that we have no solution. This system of equations is an inconsistent system with no solution.